Hello. Okay, I'm back. This is the second recording on spamming tree protocol. All right. So in my previous recording, I was talking about the bridge route, and of course, within the bridge protocol data unit, there are different aspects that I had mentioned, which include the route bridge, the server route, the bridge cost, and the timers. Okay, so in the route bridge has the lowest bridge ID, and the bridge ID, there's a priority. I did mention that the default is 32,768, but that can be changed. So the switch that has the lowest priority becomes the route bridge. And of course, you can use some commands to set that to change which one is the route bridge. So in this diagram down here, you can see the one on the top right corner is the route bridge. And actually at this point, I'm going to bring in packet tracer. All right. And as I bring packet tracer, you can see some connections that are going on with spamming tree. All right, so I will get on switch one, for instance, and go to enable. All right, and then one of the commands that you would need to be quite familiar with when it comes to spamming tree is the show spanning tree. Okay, I think I'm missing the hyphen. Show spanning tree. All right, there you have it. I'm on switch one. That's where I typed this command. You can see that. On switch one, it's there's a VLAN number one. That's the default VLAN since I haven't created any on that switch. And spanning tree is enabled, as you can see. And the priority is 32,769. Remember I had said that there's a different priority that is assigned. So if I go to this slide, okay, this slide, 32,768 is the default. So keeping 32,768 is the default. But if we come over here and go to switch one, it's showing 32,761. Why is that the case? Because you can see this is on VLAN number one. The VLAN has been added to that 32,768 plus 1, that gives you 32,769. So that becomes the priority, because the priority is a combination of that, the default, as well as adding the VLAN number, which happens to be 1 in this situation. So this is the MAC address, and it's letting us know that this is the route bridge. And we talked about the hello message, which is the BPDU, the bridge protocol data units that are sent. Those are sent every 2 seconds. And in case things change, if the switch goes down, spanning tree protocol has a mechanism of allowing those other switches to come in. Later on, we'll talk about the blocking, listening, learning, and forwarding, how that works. That becomes important in designating the route bridge. Okay, So there is some additional information down here. You can see on that switch there is this interface FA01 that's designated that this one can forward frames because it's a designated port. There are designated ports on the root bridge. You do not see the other one that we talked about was the root port. We do not see that on a root bridge. So both of these have forwarding ports. They are designated ports. They can forward frames. And the cost of that particular port or interface is 19. And of course, there is some calculation when it comes to these costs for the port. If it's a 10 megabit link, it's assigned a port of 100. If it's 100 megabits, it's assigned 19. If it's 1 gig, it's assigned a cost of 4. And if it's 10 gig link, it's assigned a cost of 2. So you can see that this is a 100 megabit link that is being used. So if we were to use different links, if we're to use the gigabit ones, that will those, since they have a lower cost, they will be the forwarding ports, the designated port, I should say. All right, so let's jump over to switch number 2. On switch number 2, let's go to show spanning tree. Okay. Oh, I misspelled that. All right. On here, we do have some different numbers. If you can see, the bridge port is 3279. It's not this it's not this one, but this is the MAC address for our root ID. This is the priority number, the same as what we saw. In cases, one thing to keep in mind, if there is a tie, if the priority number is the same on two switches, they go with the switch that has the lowest MAC address. So this is the low MAC address of our bridge. We can verify that real quick. So if I were to come over here and do a show MAC address, all right. Well, these are the MAC address that are in my that are in the MAC table, but one of that is of our root bridge. Okay, so if I were to come over here, this is our priority. We've already established that. I'm going to come down here. The root bridge. This is the port that has the fastest link to the root ID. That has that's forwarding. This is our root bridge that has a cost of 19. You'll notice that there is a designated port which is also forwarded which is a designated port. It can forward frames. The cost there is 4, but that's using a gigabit connection. We can tell by the costs as well as well, we can see from here. This is not the root bridge. All right, so switch 3 will show us similar spanning tree will show us a kind of a similar, to a certain extent, on switch number 3. And we probably could tell from this topology. From switch number 3, notice we have this port. We have the root port, which is this link right here. That's forwarding traffic frames as they come. We can tell that it's forwarding is the designate. This is the root port, I should say. It can get us to the root bridge the quickest. That is to switch 1. The cost is 19, and of course there is an alternate port which is 4. I mean, which has a cost of 4. That's blocking traffic. So on this topology, what it means is traffic will go out of both these ports, since they are designated port on the root bridge. They go to switch 2, and then they go to switch 3. When it gets to switch 3, it dies there. It's not forwarded to switch 2 because this is blocked. When it's blocked, keep in mind that it can listen. So when it listens and hears the MAC address of the root bridge, it will kill that traffic. And then should switch 1 goes down, what will happen is this will come up, so that it will still listen. Spanning tree has the mechanism of having traffic to be able to be moved around should this switch go down. But as of right now, this switch, this port on this side is down. It cannot forward traffic. But we could go to switch number 2, and on switch number 2, if we go to config terminal, we could put in the command spanning tree VLAN 1 priority 4096. All right, so when we do that, this will set the priority for switch 2. It will change it from the default of 3278. It will change it to a lower priority. And guess what? The switch that has the lowest bridge ID, or the lowest priority, becomes the root ID, becomes the bridge ID, I should say. So by this command, we can bypass things as far as which one do we want to be the bridge ID. And the same thing can be done with these interfaces as well. You can use some commands to bypass those communications, such that you can change the way that you want traffic to go. Right? So there is spanning tree protocol, the basics of how it works, and we'll cover more in the upcoming presentation. But this is it for now. Make sure you practice and play with it to see how it works.